everyone, this is Mrs. Lindsay Pereira. Today we're going to start Chapter 2, Conditional Statements. We are first going to start off with what is a deductive structure. A deductive structure is a system of thought in which conclusions are justified by previously assumed or proven statements. It is comprised of undefined terms, assumptions, which we will call postulates, definitions, and then we also have theorems and other conclusions that we have. All right, so let's dive into these a little bit more. Okay, so undefined terms. These are things that we know, but are very difficult to define. And the best example I can think of, I put a few here, are point, line, and plane. But a point, for example, how do you actually explain a point? Is it just simply a dot, a little, that type of thing? So again, we know what it is when we see it, but it is really hard to define. Assumptions, which we call postulates, these are unproven. Okay, so that is an important little part there. And they're sometimes reversible. So an example, 2 points determine a line. That is an unproven postulate. Okay. Definitions states meaning and are always reversible. So that's an important little note there. Always reversible. So an example of this, if two lines are perpendicular, then they intersect to form right angles. And again, you can reverse that. So if two lines form right angles, then they are perpendicular. Okay, so perpendicular, that little upside down T there as well. So again, they form right angles. Theorems and other conclusions, these can be proven and are not reversible. So probably the most famous one of them all, Pythagorean theorem, and again we'll learn many more of these as we go throughout the year here in geometry. So a conditional statement is something that you have, it's typically written in an if-then format. It's not always, but typically it is, especially in geometry. The if portion of it is the hypothesis, the then is the conclusion. So for example, if an angle is a straight angle, then it measures 180 degrees. An angle is a straight angle, that is the hypothesis. The conclusion is what's at the end after the then. It measures 180 degrees. Converse. If a conclusion, then a hypothesis. So this is the reverse of your conditional statement. So just be careful when you write this. Don't put if it is 180 degrees. So again, I don't really want to write it here. Well, what is it? If you reverse it, you need to keep the noun in the correct spot. So if an angle measures 180 degrees, then it is a straight angle. Okay. So again, conditional statement, if hypothesis, then conclusion. The converse of your conditional statement is switch the conclusion and the hypothesis. Okay. So again, we can kind of use variables when we're determining and talking about this. Let me move this back down here just a little bit. So if we're using variables, and you'll see this a lot, and we'll use this in our chain rule and a few different things. If P then Q, or you can use this little arrow symbol here, which usually reads implies, but you could also read it as if P then Q, but it does really simply mean P implies Q. P again is the if portion of it, so that's going to be your hypothesis, and then Q is going to be the then portion of it, so that would be your conclusion. And again, this is your conditional statement here. So if we were using variables to talk about the converse, we again would switch the hypothesis and the conclusion, so it'd be if Q then P, or again you can use the arrow Q implies P. Again, I don't care either way if you say implies or if you read it still as an if then statement. Okay, so a few things that you definitely do need to know. We talked about the conditional and the converse. But we also have two other ones. We have the inverse, which is the negation of both the hypothesis and the conclusion. So that's what this little symbol here means. This is your negation symbol. And then the contrapositive is the reverse of your inverse. So if not Q, then not P. So, for example, if an angle does not measure 180 degrees, then it is not a straight angle. Okay, so again, the negation is really referring to adding that word not in there. Okay, and we'll practice a few of these. Okay, but again, you can write it out in terms of a sentence, and then there's also times when we'll do this symbolically as well. All right, so let's try some examples here. Excuse me, write an if-then statement where applicable, then write the converse and determine if the converse is, and that's a little typo here, is true or false. So that should be is. Okay, so all kids like candy. So again, this is not an if-then format. So we want to first write that in if-then format. So again, person here. So if a person is a kid, that is our hypothesis. Then they like candy. Okay. The converse is actually, again, flipping the hypotenuse and the conclusion. So it would be, if a person, again, don't put they, if a person likes candy, then they are a kid. Okay, so again, get that noun in there. And the directions here are a little off. I actually want you to do the inverse and the contrapositive as well and determine the true or false of all these statements. Okay, so here's the inverse. The inverse is the negation of the hypotenuse and of the conclusion. So if a person is not a kid, then they do not like candy. And then the contrapositive is the reverse of the inverse. If a person does not like candy, then they are not a kid. Okay? So again, that is kind of the format of how we go through converse, inverse, contrapositive of a conditional statement. So let's go ahead and go through this and talk about if it's true or false. Okay, so we're going to go up to the conditional. If a person is a kid, then they like candy. Well, this is a little bit of, not all kids do, but most do. So in this case, we are assuming that the conditional, whenever we're dealing with these, is true. Okay, and it should be true. If it's not, something is wrong. So the conditional statement should always be a true statement. Okay, so let's talk about this. If a person likes candy, then they are a kid. Well, that is false. They don't have to be a kid in order to like candy. Inverse. If a person is not a kid, then they do not like candy. Again, that is a false statement. Okay? And then contrapositive. If a person does not like candy, then they are not a kid. That is true. Okay? So again, this is an example, not using symbols, but in terms of using if-then statements. Okay? So let's go through number 3 here. I don't know why I skipped from 1 to 3, but I did. So let's see. We identify each of these statements following the conditional statement as, what is it? Converse, inverse, or contrapositive. Then we're going to state whether or not it's true or false. Okay? So in this first one here, it says if two lines are perpendicular, then they intersect. That's our conditional. So the next one is a negation. So I definitely want to think about that in terms of our negation there. If two lines do not intersect, then they are not perpendicular. So it reversed the order and negated both of those. So hopefully you know that's a contrapositive. B, if two lines intersect, then they are perpendicular. So all that was happening here is that we reversed it. Okay, so hopefully you realize that's the converse. Next, if two lines are not perpendicular, then they do not intersect. So the negation of the hypotenuse and the conclusion, we did not reverse anything, so that is the inverse. Okay, so let's go ahead and go through and determine if these are true or false. So again, we are assuming the conditional is true. If two lines are perpendicular, then they intersect, and that is a true statement. If two lines do not intersect, then they are not perpendicular. That would be true. If two lines intersect, then they are perpendicular, and that is false. They don't have to be perpendicular. Okay? If two lines are not perpendicular, then they do not intersect. Again, that is a false statement. Okay. So now I have a little chart that I want you to actually fill in. There is no example 2, just example 1 and example 3. Go through and talk about the true and false. And plug those into your chart here, and what observations can you make from that? Push play when you are ready to check your answers. Okay, so hopefully your chart looks like this. So some observations. It appears that the converse inverse are always false. That is actually not a true statement. In our 2 examples here, that is a true statement. It is, however, a true statement to say your conditional and your contrapositive, they are both going to be true there. So if the conditional is true, then the contrapositive is true. Okay, so let's look at what is meant by biconditional statement. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. A biconditional statement is a statement that, and actually let me move this over just slightly, even though I know it's on your notes, is a statement that contains the phrase if and only if. So P, if and only if Q. So again, your symbols is using the arrow. So now as you can see, there's arrows on both ends there. Okay. Any definition can be written as a biconditional statement. And the reason that is true is because the definition is always reversible. Okay. So if we take a look here at our example, it says rewrite the definition as a single biconditional statement. Definition: if 2 angles are complementary, then the sum of the angles, the measures of the angles, is 90 degrees. So, if two angles are complementary, if and only if the sum of the angles is 90 degrees. So that would be an example of a biconditional statement using the words if and only if. All right, so we actually have a little bit of a video here, and I would like you to, you might have to paste this into your YouTube, but take a look at this. This is an ad that you would see on a TV, and I want you to come back after you have watched this video. Okay, so this is a DirecTV ad, and this is a real live example, even though, you know, it's an ad, so it's really definitely made up of what we call the chain rule. So certain events link together, okay? So what is meant by that? Let's take a look here. A chain rule is a way to organize statements, either verbally, symbolically. We will do this with a statement just like this with if-then format, but we'll also do them symbolically. So here's an example. If you study hard, then you will earn a good grade. If you earn a good grade, then your parents will be proud. So what can we conclude? Well, the very end conclusion is your parents will be proud. What is the link? Well, the link is if you earn a good grade. So basically we say if you study hard, your parents will be proud. That's kind of the end result because we link together a bunch of things in the middle. So I did not necessarily write this in terms of symbols, but I just talked about, okay, so if we initially knew what our hypothesis was, not sure all the steps in between, but the end conclusion will be parents will be proud. Again, this is an example of what we call the chain rule. We can do this also with symbols, okay? So we have a lot of conditional statements here. We have 4 of them. And in the end, we should be able to say something implies something. One hypothesis implies something. Okay, so the way I like to start this problem is I take a look and I say, okay, what letters repeat and what don't? Well, I see that P does not repeat and X doesn't repeat. So I'm going to start with one of those, and I'm going to start with the one that's on the left-hand side. So I'm going to start with P implies Q. Well, now I'm going to look for Q. So my next one's, okay, so now I see a Q here. I know Q implies R. So my link is the Q. But I can keep going with this. There's a lot more of these. So now I'm looking for, again, another R. Well, here's another R. R implies T. Well, last statement happens to have T in it, so T implies X. So all of these are my links. So I have one link Q, another link of R, and another link of T. Okay? So in the end, P implies X. That is the chain rule. Okay? Let's try another example. All right, what ones don't repeat? That's what I like to start with. So now I'm looking through and I see A. Doesn't always happen to be the first one. It just happens to be in this case. I'm looking through, I see a T, I see a Y, D, even though it's negated, I still see an S. It looks like here that maybe, no, T, I got a T, I got a Y, Z, and, yep, Z. So this one or this one. So I'm going to actually start with A, because it's on the left-hand side. So A implies B. Now I need to find my other B. Well, I have a B here, it's negated, it's not on the right side. But remember, if your conditional statement, which is what this is true, then your contrapositive is true. Your contrapositive statement to this is reversing the conclusion and the hypotenuse, negating both of those. Well, if I negate a negation, it just simply becomes B implies D. So I negated both of these, so they become just simply B and D, and then I reverse the order. This is what I now need to use for my next step. Both of these are true. This is your conditional. This is your contrapositive. So there's my link. But now I got to find D. So I'm looking over here. So there's D implies S. Now I need to find S. Well, again, here's where S is. So I need to think about the contrapositive. So some people like to think of this as the conditional and this is the contrapositive. That's fine either way. Again, it's kind of interchangeable with that. But I definitely want to do it where S is on the other side. So again, that's my link. Okay. Now I'm looking for T. T implies Y. And then last but not least, Y implies Z. So there's my remaining links. So in the end, A implies Z. Okay, so this is where you have to think about it definitely a lot more when you have your negations in here and you have to take and use your contrapositives and conditional statements to switch the order. Okay, so these are examples of the chain rule. And I'm going to leave the notes off with, again, another YouTube video. If you'd like to watch this one, again, it's another DirecTV ad, so feel free to watch that. Otherwise, we are done with notes from section 2.1.